Alright, this video is going to be about finding minimum, maximum, and intersection of functions. We're going to start by finding minimum for a simple function, both algebraically and graphically. Then we're going to do the same thing, but with a function in a specified domain. And in the very end, we're going to be finding intersection of functions. As usual, this is our predefined function, and we want to find the global minimum of this function algebraically first, right? And in order to do this, oh, by the way, if you guys are using the Ti-nspire software, and you can press this menu button in the document view. So we have to switch to a less friendly view, but yeah, it's okay. And let's get started. The first step is you're going to press menu and then go to calculus and then find function minimum here. If you want to find maximum, it's exactly the same steps and following process, but you'll just choose maximum here. For now, we'll go with minimum. And if we look at the documentation for this function, basically it requires an expression and an independent variable. So we're going to type in our expression here and independent variable x here. So we get x equals 0. This is the x value at which the function minimum occurs at, right? And we just have to substitute this 0 back into the function, and we can get the global minimum. All right, this is how you can find the global minimum of a function algebraically, and I'm going to show you guys how you can find it graphically. So in order to plot things, you have to create a new page because apparently you can't graph anything here. How to do it is by pressing Control and then Document. So now you've added a new page and you can add graphs here. We're going to just type in the f of x we defined, which is x squared. Yeah, this is x squared. And to find the minimum of this function, we'll go to Menu, Analyze Graphs, and you can see the minimum here. If you want to find maximum, it's again the same thing, but we're finding minimum now. And you need to specify the lower bound and the upper bound. And see, now we get the function global minimum. And the thing that you have to be cautious here is that because now we're dealing with a relatively simple graph and we know like this is the local minimum and the global minimum, but if you're dealing with a more complicated graph where there's like multiple local minimums, you have to be careful and like make sure you are seeing the whole picture, or the graph is not curving up here and then somewhere else is curving down. Yeah, you just have to zoom out to see the whole picture. But for this simple graph, this does the trick. Right, so now we're back and we want to find the minimum for the same function but within the specified domain. And how we do it algebraically is this is actually magical. Like if you see the documentation for fmin, it actually doesn't specify any extra parameters, but if you actually try doing fmin f of x and then from 1 to 2, it actually like takes this as the lower bound and this as the upper bound and gives you the correct answer. Yeah, and also like now we know the function fmin, we don't have to go to menus and then find it again. We can just type it out. It's much more faster and efficient. Yeah, and this is basically how I do it algebraically. But a problem with this is that doing it algebraically is difficult to catch local minimas because you kind of have to guess the domain first. But doing it graphically kind of solves the problem. And so we're back to our same function, and now we want to have the domain to be from 1 to x equals to 2. So how do we change that? It's actually really easy. Like you can just use the same technique, menu, analyze graph, and then find the minimum. And now, yeah, this is something cool I just learned. You don't have to like go accurately here and try to find 1. You can just type 1 on your keyboard, and this sets your and press enter, and this sets your minimum to be x equals to 1. And then you also don't have to scroll to find 2. You just type 2 and then enter. And this specifies the domain to be like the bound to be 1 to 2. And yeah, this is pretty cool. And now we can get, this is like the minimum of the function from 1 to 2. And yeah, that's basically 2 ways that you can find minimas within a specified domain. And I'm just going to go ahead and show something like even cooler. So now if we want to redefine our function to be, let me just think of random function, maybe x to the power of 3 minus 1. All right, and x to the power of 3 minus 1. And what you notice when we switch to the graphing panel is that because we like define this f1 of x to be f of x, so that it actually changes when we changes the definition of f. So now we have the graph of x cubed minus 1, and we actually also have like the minimas within the domain. And yeah, that's something cool. All right, and we're going to talk about our last topic, which is finding intersections. So this is going to be done pure graphically. And now say if we have another function, f of 2 equals to 1. That's, yeah, easy function. And we just go to the same place where we did the minima. So we go to analyze graph, but now we go to intersections. And you just specify the lower bound and the upper bound. And you can find, let me move this one away. And you can find like the intersection of these these two functions. And it's going to be useful very, very soon. All right, that's pretty much for today. And yeah, hope you guys can subscribe and like. Thank you very much.